The lectures this week are about using SPSS, a statistical package, and how to use the various techniques that we've been talking about within the lectures up until now, so weeks 1 through 4. I strongly suggest that you download these programs to also have available for other classes, as they do contain valuable information of kind of walkthroughs of how to do various tasks in SPSS. And I encourage you to use them as necessary. So today's set is going to be talking about how to calculate descriptive statistics. And if you've watched the SPSS slide deck on correlations, regressions, and scatter plots, you can also get descriptive statistics through that technique as well. But sometimes that's all we're wanting to, or we want more advanced descriptive statistics. We're also going to talk about how to calculate and create frequency distributions and histograms. And again, in the lectures that I've been giving within this class, I've been giving examples of both of these. Frequency distributions and histograms we've been using. Well, I want to talk about how we actually calculate them and create them in SPSS. So let's start with simply descriptive statistics. So if we're wanting to look at the descriptive statistics of a data set, the first thing we're going to do is open the data set. Now, with descriptive statistics, we can look at all types of variables. So we can have variables, for example, that are simply dichotomous. So there's only two levels. For example, it might be pass, fail, male, female, true, false. We can be looking at continuous data. We can be looking at categorical data, for example, demographic data, what particular region someone is from, or perhaps their race or ethnicity. So we're going to select Analyze Descriptive Statistics, and in this case, we're going to start with frequencies. Once we select that, we're going to actually be given a list of all our variables. So once again, the variable list is on the left-hand side. For each variable that we want to have descriptive statistics for, we're going to click on the left-hand side version. We're going to hit the arrow, and we're going to bring it over to variables. You can bring over as many variables as you want. As few as one, and as many as every variable in your data set. Once we have that, we're going to click on the statistics box. Statistics is going to bring us to this screen. Again, we're going to have some more information than we actually need for the most part. There is information on quartiles, so if you wanted to divide up continuous data into quarters, bottom 25%, low 25%, high 25%, and top 25%, that's something you would put in. If you're actually wanting to look at a cut point within your data, how many people passed a certain score, you could do that as well. You could also collect percentiles. There's a lot of things you can do here. We're going to skip all of that for the most part, and we're simply going to ask for mean. Now notice you could also select median, mode, and sum. So if you are wanting to get the mode, the most common response, the median, a non-mathematical or non-arithmetic center of your distribution, or if you simply wanted to add it up, you could select those as well. But for the purposes of what we're doing in this class, we're simply going to look at mean. We're assuming here that we're looking at data that is continuous and relatively normally distributed. Note that when you select mean, you are going to also get the mean scores for data that it makes no sense. So for example, if you had a geographical region, urban, suburban, or rural, and you had coded that 1, 2, 3, you're going to get a mathematical mean. That mathematical mean is useless at this point because that data is not continuous, it's not numerical in a sequential manner, and it's not equal distance. It's simply numbers representing categories. We're also going to click standard deviation, and notice again, we could select some of the other measures of dispersion. In other words, different measures of variance, such as we could ask for simply the variance, the range, minimum, maximum, etc. For this purpose is again standard deviation. Now again, standard deviation makes the assumption that we have continuous data that's normally distributed. We're still going to get values for standard deviation for even our categorical data. So it is up to us to properly interpret what we're getting from this particular example. One of the ways you can avoid this problem is to run this analysis twice. Once you could actually be looking at just categorical data, and in that case you wouldn't select mean, you'd select mode, and instead of standard deviation you might select minimum and maximum just to make sure there isn't any odd numbers. And then you could run this analysis for all your continuous data with mean and standard deviation. However, we're going to be getting most of what we need from one table, so we might as well just run that for all of our variance. Notice you could also click skewness and kurtosis if you were wanting to test to find out if your data was normally distributed. We're not going to do that in this case, but it is an option as well. So again, we've selected mean, we've selected standard deviation, we're going to hit continue. We're now going to click charts. In the charts, we're going to click histogram, and this is how we're creating a histogram from our descriptive data. We're going to show a normal curve on the histogram. So this is basically going to show us what does it visually look like within our data sets. So for every particular percent, or for every variable, it's going to make a histogram for that variable and show a normal curve against that histogram. And again, we're going to click continue. Now, again, I want to really caution you that histograms usually make sense with continuous numerical data. We're still going to generate histograms for other things. It's up to you to interpret that. That's going to bring us back to our original table. We're going to click OK, and we're going to get our results. So in this case, I'm simply looking at two variables. So we're going to get the means and standard deviations of those two variables, so what the means are and the standard deviations. We're also going to get frequency and percent. So basically, for each of these variables, it's going to tell us how often did someone select 1, 2, 3, or 4, and what was the total number of applicants, and what that percentage was. So in this case, 51% responded 1, 20.8% responded 2, 14.7% responded 3, and 10.5% responded 4. So we can already look at this and go, this is probably fairly skewed data. Most people took the lowest option, with very few people selecting the top option. And we're also going to see that for our next variable. So again, our frequency, again, it's on a 1 to 4 scale, and we're going to see those percentages. And again, we're going to see that in this case, again, it looks like it skews fairly low. Though notice that we actually have some half scores in this data set. So 1, 2, 2.5, one person responded to 2.5. Now, if that's an allowed response, that makes sense, and that's fine. It is also possible that that is a missed key, that the person entering the data entered either a 2 or a 3 as a 2.5 instead of a 2. I would probably go back and check that number if it doesn't make sense. And that's one of the advantages of the frequency table, is we can also see if there's wrong data. If we know it's a 1 through 4 scale without any halves, we know that's probably inaccurate. If it's a 1 through 4 scale and there's a 5, someone probably accidentally hit a 5 when they were trying to enter a 4. It again gives us some information about potentially wrong data. So here's those histograms, adopt 3 and open 4. So this is basically whether someone would adopt a new method and also how open they are to that new method. So again, you can kind of see our data here, not really reflecting normal distribution curves and actually looking fairly positively skewed.